Welcome to our second compiler design video, everyone. We're going to be introducing ourselves to context-free grammars and parse trees in this tutorial. Well, a context-free grammar is a four-tuple, which, just to remind you, means it effectively has four components. V, its non-terminals, sigma, its terminals, P, its productions, and S, the start symbol. Now, the non-terminals are symbols that end up as terminals, but go through patterns or can, through productions, can produce different sorts of combinations of terminals and other non-terminals, or themselves too. Now, to make things more clear, terminals are effectively strings or characters of a particular language, and that's going to be the language that this context-free grammar represents. So context-free grammars are made to represent a language. They're made to be able to parse a language. Now, productions, as you can see here, are openings of non-terminals into either terminals or a combination of terminals and non-terminals. Or it can just be non-terminals too. It can just lead to another non-terminal. Now, you'll note here, we have A goes to left bracket, B, right bracket, or B, or ID. Now, the ors here could also be represented as A goes to B, for instance, instead of this. But this just makes things much more convenient. You don't have to write out A goes to every single time. So let's just add this right back in here. Now, the start symbol is a terminal that, you guessed it, it's the start symbol. It's the terminal that starts the grammar. In this case, it's A, and for this grammar, it's A as well. Now, what can this particular grammar that we have here represent? Let's say we wanted to parse ID times ID plus ID. Could we parse this with this grammar? Is this a member of the language that this particular grammar represents? Well, let's see. Now, to start with, to make a parse tree, we're going to make our root node the starting symbols, or the starting non-terminal, which is A. And let's see, well, A, we're going to open A out into B, because that seems to be the most logical thing to do in this case, doesn't it? Because this string doesn't have any brackets in it, so we don't need brackets. And then, by the way, this in this production, the brackets are non-terminals. The brackets are terminals, and B is a non-terminal. You can tell because each non-terminal has a production associated with it, where it opens up into a combination of terminals and non-terminals, or just terminals in the case of C. Now, what we do next in that case is to point A down to B, okay, we've represented our first production. And what can our next production be? Well, we've got a plus here, so we might as well have C plus C, mightn't we? So what we can do for this is to have three arrows pointing out, because this production, it has two non-terminals and a terminal, so it's going to open up into three different symbols, effectively. And we can make our first arrow C, the second one plus, and the third one C, because we want it to be in the same order that this production opens up in. So let's make a node for this. Let's make a node for this C. And then the non-terminal, the terminal plus can just be a leaf. So we don't need to make a node for this. And if you're unfamiliar with the terminology for trees, nodes are any points in a tree that aren't a leaf. So they're points in a tree that open up or that lead to other nodes or leaves. And leaves are the bottommost points in a tree. Now, these are both going to be C. And what can these C's open up into? Well, we see here that C can produce ID times ID and just ID. So why not make the left one give it 3 arrows and we make it ID times ID. And then we can just make the right one go straight to ID. And now we have ID times ID plus ID as our leaves. So we've managed to parse ID times ID plus ID, and we've managed to produce a correct parse tree. That means that ID times ID plus ID is a member of the language represented by this grammar. Now, what isn't a member of the language represented by this grammar? Well, let's think for a second. We could, for example, try and have ID plus ID plus ID times ID. Can this be represented by the grammar? Well, if you look carefully at the grammar itself, you can tell that it can't be, because, well, A goes to B, B goes to C plus C, and then we end up with 1 plus, and there's nothing else we can do. There's no way we can get the second plus. Now, a grammar that can pass this would be this grammar. And you might notice that there's only one non-terminal, A. And these could all just be on the same line, and we could have A goes to left bracket A, right bracket, or A, or ID, or A plus A, or A times A. But let's make things a bit neater. And let's try and pass ID plus ID times ID on this second grammar. So again, to start with, let's make our root node, and let's call it A, because that's the starting symbol. And what should we open this up into? Well, we can just do A plus A, can't we? Because we have a production, A goes to A plus A. So let's have a plus here in the middle. And again, let's make sure all of these are arrows. We can split this. So what do we need for these two? Well, we need A's. So we need an A on the left side. We need an A node on the right side. Let's label these. And what should these open up to? What should these produce? Well, we need another plus. So we could make one of the A's A plus A. Because as you can see, each A can produce A plus A. So let's try that. A plus there. And then two more. Oh, wasn't quite right. Position. Okay, two more A nodes. Okay. Now we have A, don't we? To finish the ID plus ID plus ID bit up, we can make all of these A's into IDs. So just arrows, ID, but we actually can't because we need the times, don't we? So we need to make the last A into A times A. And then we can have these two A nodes again. Okay, now we have ID plus ID plus, and we're reading this from left to right. So we go through the bottom left node all the way across, going up like that and like that. So ID plus ID plus, well, we've got A for now, but that's going to become an ID, isn't it? Oh, sorry, yeah. Let me just take that back. It's going to become an ID, not a times. So we've got ID times and then another ID. So we've managed to parse ID plus ID times ID with this grammar. We've managed to output a parse tree that can represent ID plus ID plus ID times ID. So I hope that's given you a nice introduction to context-free grammars and parse trees. We'll be going into more detail on how we can use these in the context of compiler design in later videos. But I hope you enjoyed, and see you next time. Thank you very much for watching.